Okay, let's talk about the types of business situations that can be detected and analyzed using an X bar chart versus an R chart. Okay, now again, we always make these together. And when do we make them? What kind of data are we dealing with here? We're dealing with variables data, stuff we can measure, right? Amount of pounds of stuff in a box, right? The temperature of something, the weight of something, the amount of electrical resistance in a circuit, and so on. Anytime we're dealing with that type of business situation, we've really got kind of two different things that we care about. One is the average, and one is the amount of dispersion around that average, or the range is one measure of dispersion, and that's what we measure with the actual R chart. But I'm going to write dispersion here because that's really more generally what we care about. Okay, and students seem to really struggle understanding the difference between these two different things. So gotta let me see if I can come up with an example here that might help. So let's say you operate a restaurant, and it's a fancier restaurant, busy restaurant, and you don't take reservations, but people just come in on, let's say, Friday nights. They have to put their name on a list to get a table, and let's say that the average time it takes for them to actually get a table once they put their name on the list is 30 minutes. All right. Um, about the quickest they ever get a table is 25 minutes. Let's say that's the minimum, and the maximum, let's say, is 35 minutes. It really never takes more than 35 minutes to get a table. Okay. So again, the average is 30, right? The range here is 10, right? The difference between the minimum and the maximum. We could also think about this as, let's just say we randomly, um, every night, or let's say every Friday night, we just randomly, look at three different sort of encounters, when a customer comes in the door, and we actually track, and most nights it looks something like this, right? If we took a sample, typically we'd see like something right around 25, something right around 30, something right around 35. Okay. Um, so if you'd probably be pretty happy with that, right? Because the type of restaurant that you run, customers expect a wait, right? If they didn't expect a wait, they wouldn't come in the first place. But customers implicitly sort of have an expectation about how long that wait's going to be, right? And if you tell them, you want to be fairly accurate, right? So customers here would probably be pretty happy, right? But let's say you make some personnel changes at your restaurant, or who knows what. And let's say that maybe a month later, all of a sudden, the average is still 30, but some customers can take up to 50 minutes. Some customers as little as 10 minutes. Well, these customers are pretty happy, right? These customers, they kind of got what they expected, but these customers are really, really not happy, right? And these are the customers that are going to remember that there was a problem, right? Or when it's 50 minutes, they're going to remember it was a problem. They're probably not going to remember the 30s and the 10s, and they're going to be a whole lot less likely to come back, right? So that's a problem, right? Especially in service businesses, meeting customer expectations really matters. So let's think about what's going on here, a little bit in terms of statistics. What's the average in both these situations? Well, again, the first one, the average is 30, right? And in the second one, the average is 30, right? So if you're just looking at the average wait times, you wouldn't really detect that there's something going on here. There's probably a problem, going on here, right? But if we look at the dispersion, or we look at the range, here the dispersion, the range is 10, right? Um, and here the range is a whole lot more. That's 40, right? The range has really gone up, right? The variability around that average has gone up, and because of that, some customers are going to be really unhappy, right? You're going to have a lot harder time, um, uh, credibly telling a customer when they walk in the door how long it's going to take for them to get a table, right? This is not such a good situation. And again, it's detectable with the range. All right. Um, so, that in statistical process control terms, that would show up on an R chart. If you made an R chart and your range shifted, that drastically, you would probably see a point outside the control limits. That would show, an out of control situation. On the other hand, your X bar chart's not going to, that's just, kind of 2 points, the same stable average. You're not going to show a problem at all. Okay, so let's think about, let's go back to the same situation here. Typically 30-minute wait. The most it ever seems to take is about 35. The least is about 25, and it's about 25's happened about as much as 35. So the average is 30. Okay, but again, let's say something happens, something changes, new employee, who knows what. And now let's say the average, if we it typically takes about 40 minutes. Max is about 45, min's about 35. So again, this could be like, we just sample 3 different, customer encounters, and we time how long it takes the customer to get their table, right? Or this could be a statistical distribution. It doesn't really matter, right? So what's changed here? Well, the range hasn't really changed, right? The difference, the range here is 10 in this sample, right? And the range is 10 here in this sample, right? So either way, we can pretty predictably tell a customer plus or minus 5 minutes how long it's going to take them to get a table, right? So that's pretty good, right? So an R chart would show the situations in control, right? R chart, all good, smiley face. Okay, but what's happened to the average? Well, here the average is 30, right? And here the average is 40, so the average has really gone up, right? And if you own this restaurant, you would probably say, hey, there's something going on here. I got to figure this out, right? And this would be very obvious to you if you did statistical process control, and it would show up on the X bar chart. The X bar chart is going to show not happy, right? It's going to show it's probably going to be a point above the upper control limit. So that is the difference between shifts in dispersion, which we actually talked about first, and shifts in averages, which we talked about second. As a business person, you need to be aware of both those different things and sort of understand how to analyze and test for both those different things.